Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is linear algebra, first major examination, term 041 or 241. Yeah. Uh, Let us have a look to the exam and solve it together. Answer each question. The inverse of 2a is given. Find the matrix A. Well, if we call the inverse of the matrix 2a, if we call it B, so this matrix is the matrix B, then if we take an inverse of both sides, 2a will be equal to B inverse, and then A will be equal to half B inverse. So all what we need is to find the inverse of B and then multiply by half. So the inverse of B, this is a 2 by 2 matrix. We multiply 2 times 4, 8, minus 3 times 3, 8 minus 9 is -1. This is the determinant. And 2, 4, we change their positions. 3, 3, we change their signs. So just multiply 4 over -2. That's -2, -3 over -2, and -3 over -2, and 2 over -2. So that's the answer. Find the value of y. Well, here you can say that I have a matrix A and a matrix X equals matrix B. So to find X would be A inverse times B. So in fact, XY will be the inverse of this matrix times the matrix -1 and -2. To find the inverse of this matrix, again, 1 over the determinant, 2 times 4, 8, minus 1 plus 1, 8 plus 1 is 9. 2, 4, we change positions. -1 and 1, we change their signs. Now to multiply, I will keep 1 over 9 outside, and I'll multiply these two matrices. -4 minus 2 is -6. 1 minus 4 is -3. So finally, -6 over 9 is -2 over 3, and -3 over 9 is -1 over 3. He's asking about y, so y is -1 over 3. Trace a square. We find a square by multiplying a times itself times a. This is a square. So 4 plus 18, that's 22. Since he is asking about the trace, so I don't need to find these two numbers. I'll find this number on the main diagonal. So multiply the second row by the second column. 6 times 3, 18, plus 4 times 4, 16. 18 plus 16, that's 34. If you want to find the answers and write here 18 and 36, that's okay. The trace of a square is 22 plus 34. This is the definition of the trace, so it is 56. Find the distance between the point and the line. Well, we have a formula. If the point is x0, y0, and the line is ax plus by plus c equals to 0, then the distance is absolute value of ax0 plus by0. This is a formula in chapter 3, plus c over square root of a square plus b square. So if we apply the formula, we have 3 plus 8 minus 5 over square root of 9 plus 1. So in fact, the answer would be 6 over square root of 10. Find the vector component of u along A. Well, that's the projection of u along A, and the definition is u dot A dot product over norm of A square times the vector A. U times A is negative 2 minus 3 over norm of A square is 1 plus 4 plus 9 times negative 1 to negative 3. This is negative 5 over 14 times negative 1 to negative 3. So the answer is 5 over 14, negative 10 over 14, or negative 5 over 7, and 15 over 14. To compute this, this is a dot product. 4u dot u will give you 4u dot u, then plus 4 times 2 is 8. These are the properties of dot product. The constant comes out, and negative 3v times u is negative 3v times u, and then negative 6v dot b. U dot u is the norm of u square from their definitions. U dot v is equal to v dot u, so 8 minus 3 is 5, and v dot v is norm v square. Norm of u is given, it's 5, so square it, and u dot v is given, and norm v is given, square it. So 100 minus 20 plus 6 times 49, the answer is negative 214. Solve the linear system either by Gauss or Gauss and Jordan method. Well, the first step is to write the augmented matrix. These are the coefficients of x1. These are the coefficients of x2, the coefficients of x3 in all equations, the coefficients of x4, and then the constant terms. Well, this is the augmented matrix. This number must be 1. It is 1. So I'll use it to change 2 and negative 1 to 0. So negative 2 R1 plus R2 and R1 plus R3. The new matrix would be the first row, there is no change. Now the second row, negative 2 plus 2 is 0. 2 plus 1 is 3. Negative 4 plus negative 2 is negative 6. 2 minus 2 is 0. 2 minus 2 is 0. And 1 plus minus 1, 0. Negative 1 plus 2, 1. 2 plus minus 4 is negative 2 minus 1 plus 1, 0, 0. Now this number must be 1. So I'll interchange row 2 and row 3 to have 1 in the second row, second column. So the first row as it is. Now the third row will be the second row, and the second row will go down to be the third row. Now this number is 1, so I'll use it to make the 3 0. So negative 3 R2 plus R3, And I'll make -1 also 0, so Gauss and Jordan. So R2 plus R1. So I'll have 0, 1, -2, 0, 0 without change, and add 0, 0, -1, -1, and -3 plus 3 is 0, 6 plus -6 is 0, 0, 0. So that's it. That's the last step. Let me write the equations again. X1 minus X4 is -1, and X2 minus 2X3 is 0. Now, the leading ones, I have 1 here. So X1 is basic. X2 is also basic. X3 and X4 are free variables. So I let X3 equals T1 and X4 equals T2, for example. Then from here, X1 would be -1 plus X4, which is T2, and X2 would be 2X3, which is T1, and T1 and T2 are parameters, any real numbers. So that's the answer. Find determinant of A transpose times A. Let us first find A transpose times A. Well, this is A. The transpose would be you change the row into a column. So this is the transpose times A. Now the size of this matrix is 2 by 1, and this is 1 by 2. So when I multiply, I get 2 by 2. So 3 times 3, 9, -6, -6, -2 times -2 is 4. So what is the determinant of ATA? It would be 4 times 3, 36. -6 times -6 is 36. So the determinant is 0. Use matrix multiplication to find the reflection of this point about the YZ plane. Well, the standard matrix for this reflection is -1, 0, 0, 0, 1, 0, 0, 0, 1. It is in the table in chapter 1. So we multiply this matrix, the standard matrix of this reflection, by the points, and we will get -3, -2, -1. So in fact, the reflection of this point about the YZ plane is the point -3, -2, and -1. This is T1 transformation, and this is T2. Find the standard matrix for the composition. I need to find the standard matrix for T1 first. So this is the definition of T1. The first component, I have x1, x2, x3. So the coefficient of x1 is -2. There is no x2, and the coefficient of x3 is 1. The second component, I have -1, -3, and there is no x3. So this is the standard matrix for T1. Standard matrix for T2, I have 1 and 2, the coefficients of the first component, the second component 4 and -1. Well, he is asking about the standard matrix for the composition. By definition, it is the standard matrix of 2, T2 times the standard matrix of 2, 1. So I will multiply 1, 4, 2, -1 by -2, -1, 0, -3, 1 and 0. 2 by 2, 2 by 3, I'll get a 2 by 3. -2 minus 2, that's -4. 0 minus 6. I'm using the first line, 1. Now the second line, negative 8 plus 1, that's negative 7, and 0 plus 3, and 4 plus 0. So this is in fact the standard matrix for T2 circle T1. Find the formula for T2 inverse. Well, I need to find the standard matrix of T2 inverse. And by definition, it is the inverse of the standard matrix of T2. Well, T2, that's the standard matrix of T2, 1, 4, 2, negative 1. So I need to find the inverse of this matrix, 1 over the determinant, negative 1 minus 8, that's negative 9, 1 minus 1, change positions, 2, 4, change signs. So the answer is 1 over 9, 2 over 9, and 4 over 9, and negative 1 over 9. He is asking about the definition, the formula. So let us write now the formula. T2 inverse of W1, W2 would be equal to the first component. These are the coefficients of W1. These are the coefficients of W2. So 1 over 9 W1 plus 2 over 9 W2. And the second component, 4 over 9 W1 minus 1 over 9 W2. Use Cramer's rule to solve the linear system for y only. Well, if we want to solve it for y, then y equals the determinant of ay over the determinant of a. The determinant of a is the determinant of the coefficient matrix. So let us write the coefficients of x, the coefficients of y, and the coefficients of z. Let us find this determinant. I have 1 here and negative 2, 2, so I'll make these numbers 0. So I multiply row 1 by 2 and add it to row 2. And negative 2R1 plus R3. So the new determinant would be, notice that these transformations do not change the determinant. So I have 1, 1, negative 2. This is a determinant. And 2 minus 2 is 0. 2 minus 4 is negative 2. Negative 4 plus 1 is negative 3. And negative 2 plus 2 is 0. Negative 2 plus 1 is negative 1. And 4 plus 2 is 6. And to evaluate this determinant, I'll use cofactor expansion along the first column. So 1 times the minor. The minor of 1 of this one is negative 2, negative 3, negative 1, and 6. So you cancel the row and the column. Okay. And then negative 12 plus 3, negative 9. So the determinant of A, let me check, negative 12. This is minus 1 times minus 3 plus 3, so minus 3. So sorry, this is minus 3, so minus 15. So determinant of A is negative 15. Well, the determinant of AY is exactly the same as the determinant of A, but changing the column of Y, we change, this is the column of X, keep it, but the column of Y should be changed by the constants, negative 3, 1, and 2. So again, I'll use the same transformations. I'll multiply row 2 by 2 and add it to row 2. And negative 2R1 plus row 3. So I'll have 1, negative 3, and negative 2. And this is 0, and this will be 0. And this is negative 3, 6 like this will not change. But what's changing here is the second column. -6 plus 1, that's -5. And -2 times -3, 6 plus 2, that's 8. And now find the determinant using cofactor expansion along the first uh, row, the first column, sorry. So let me use another color. And then the determinant would be 1 times the minor, which is -5 minus 3, 8, 6, and -30 plus 24. That's -6. So the answer is 6 over 15, or if you divide by 3, 2 over 5. Find the cofactor of the element in the second column, third row. So we need to find the cofactor of this element. So it's equal to -1 to the power 5. So it's -1 times the minor of this element. We remove the column and the row and write the minor 0, 0, 2, 5, -1, 22, 2, 7, and 8. Now this determinant is easy to evaluate. I'll use cofactor expansion along the first column. 0, 0, I have this 2, positive, negative, positive, the sign is positive. So this 2 will come out, and I will remove the row and the column. So I'll have 5, 2, this is the minor of this element 2. So it is the element times its cofactor. This is a difference between finding the cofactor itself and find the determinant. We find the determinant by multiplying the element by its cofactor. So the element here is 2, and the cofactor is this one. So the answer is -2 times 35 plus 2, that's 37, and the answer is -74. This is the last question in the major. I hope you enjoyed solving this equation solving this major with me.